Begin with our final speaker of UICC, at least for the student portion anyway. All right, so our final speaker of the day is, he was the former director of technology for Ask.com, and he has had a very impressive resume, but he's asked me to keep the introduction short. So I'm just going to kind of get to it. He received his PhD from the University of Iowa in 2014, actually back in December. So please help me welcome Alessio Signorini.
Hello. Does it work? Yes, it works. Hello, everyone. As I said, I got my PhD here in December. Got my PhD largely thanks to those two people. You probably know Alberto Sega, who was also my advisor, and Bruno Codenotti was a visiting professor here and a friend of mine from Italy. Those are the ones that introduced me to how the US system works and application to universities and so on. And those are the ones who introduced me to Iowa, which is a state that in Italy we don't know about. We know about California, thanks to Baywatch. We know about New York, because it gets destroyed in most of the movies. But Iowa is not, and my family did not know where Iowa was. So for like the years I lived here, I was living in Chicago for everybody in Italy. And when I arrived, I loved it. I arrived here August 13th at night, August 14th, 2004. Yes, it took me 10 years to get my PhD, and you will discover why. But when I arrived here, I loved it. You know, there was sun, and there was trees, and birds, and the buildings were awesome. And you know, I did my high school and university. I come from Italy, where you believe everything is great. But this was my high school. That was my university. So when I got here, it looked fantastic. And you guys got everything right. Like now, you have water fountain. We have to pay for water in Italy. You got like sports, and you got like a bus system that actually works. And I remember I calling my mom, "Mom, these people have buses are free here." And Mom, like, "Free buses? That's crazy talking." It's like, no, it's awesome here. I love it. I love it. And I loved it. And I loved it. And people were nice, and everybody is friendly. I still have plenty of friends, and I got to see them. And I loved it. I loved it. Until tornado season arrived. Alberto never mentioned tornadoes in the application. It's not in the pamphlet, nor in the university website. And the first time that I was in my house, my little apartment, and the first time that this came up on the screen, I freaked out. They didn't tell me what to do, so I did what the only thing, I ran to the basement. I took my a torch and my computer, because that seemed a good idea, and I sprang to the basement. And then I stayed in the basement for 2 hours, because nobody told me what to do and after. And I was there thinking, what do I do now? What happened? I thought I would see this coming out. And I said, oh my God, I moved here, I should not. I should have stuck with California or whatever. And then I came out, and everybody was like this. And then there were kids flying kites and stuff. I was like 2 hours in the basement. And, and then, okay, I can deal with tornadoes. It's okay. And then winter came. And that this was also not in the pamphlet. Like, the minus 20 temperature are not something you know about. And so, that was challenging, but that gives you time to do research and ideas, which is good for a PhD student. That's what you're supposed to do. And in fact, a few months after I was here, I already thought, I don't know why I was working on something, and I had my first idea, and I went to Alberto, super excited. I thought, okay, images are done by pixels, and a computer represents those colors with numbers. And this is hard to compress. My idea was to compress images without losing details. For some reason, I wanted to do that day. And so I thought, instead of doing this, I can get the difference from the pixel nearby. So, I just store the difference as opposed to those numbers. And so you get a lot of very small numbers, and a lot of very small numbers, it's easy to compress. Much better than this, because you will get a lot of zeros, you got to 1, because colors generally are similar in similar things. And I thought, I'm a genius. I felt like a Will Hunting, in a Good Will Hunting in the movie. And I worked on it the entire weekend, and then I ran to Alberto on Monday morning. I have this genius idea, and Alberto didn't say anything. He didn't say, like, oh, you're an idiot. So I said, okay, this is a good idea. But he told me, you should do some research and see if somebody ever done something like this. And they could not possibly have thought that. But he didn't say that. He encouraged me to do research. And so I went and I figured that they invented this thing in 1993. It was called JPEG lossless. You guys probably figured it out. So, but it was a little bit sad. But I knew now I wanted to do research, and I wanted to learn how to do research, and it was great. And so, everybody was doing research. Everybody was working on something interesting, something that they're very passionate about at the university. I remember Rajiv was my office mate, was a PhD student as well. Some of you may have known. And one day I got back to our office, and the whiteboard, or blackboard at the time, looked exactly like this. I had no clue what he was doing, but it was very cool, and I wanted to do that too at some point. And he was working on some coloring problem. And I didn't think coloring was a very big deal, because I couldn't figure out why he was having such a big problem. And then he was talking about graph coloring problem, which was another thing very, very, very complicated. And everybody was doing this very complicated stuff and that I didn't know about. And I was wondering, OK, I have to do something, otherwise Albert is going to deport me. So what I'm going to research on, I don't know. I figure, OK, I can count how many pages there are on the internet. Nobody knew at that time. I learned how to count in Italy. The internet is there. I can probably figure that out. And so I wrote a software, and I installed it in all the computers of the computer lab and ran it for, and after a day, I met the IT department because they disabled my account, and because apparently, even in 2005, it was not cool to try to download the internet, which is what I was trying to do at the time. And then we found an agreement. I bribed them, and it worked, and things. And I finished my paper, and I got a paper published. And so in 2005, if you want to know, there were 11.5 billion pages on the internet. And now there are many, many, many more. But that was 2005, and that was cool. And that was my first research when I got here. And that spurred a lot of interest from companies, big companies. And they offered me jobs. And then I ended up accepting Ask.com because Google was very cool. They just went public. Yahoo was very big. But I felt that if they were already so big that if I went to one of those, I would not have made a difference. I would have been one of the many. I mean, they already had thousands of employees. Ask.com seemed small enough. And so I went to Ask.com, Ask Jeeves, where my point was to convince you guys that there was a butler answering the questions as opposed to machines. And we succeeded in doing that. And so whatever you do in life, after computer science, studying computer science, even if you do a startup, I strongly, strongly, strongly recommend you to do at least a few years of experience in a big company, because it will teach you a lot that you don't learn in a startup. So do both, and then decide what's for you, what's best for you. And so in Ask.com, I took care of a lot of interesting problem classification, search, ranking, indexing, scaling, stuff that are very, 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 very big. But one of the most interesting things I did in Ask.com is that towards the end, when I was the director of technology, I worked for the parent company, which was called Interactive Corporation. Interactive Corporation owns a bunch of things, and you may know some of those. And one was interesting because I got to work with a lot of data, like Match.com, OkCupid, and stuff data. They are so cool what people do there. But it was also interesting, my job at IAC, because I was doing something that's called technical due diligence. So whenever a company wanted to be acquired by IAC, or IAC was interested in a company, I will be put together with the founders, the people there, and I will try to estimate how much it will cost to IAC to build that company from a technological perspective. And I got to see a lot of cool startups. Like I was one of the first people to see Siri. Siri, that now is on your iPhone, was a different company. It was very, very much smaller. It was text-based. And that was one of those days in which I was sitting on the table, and I wished to be on the other side of the table, because it was not tremendously complicated what they did, but it was very cool idea. I also saw Twitter. And Twitter, from a technical perspective, when I saw it, I said that it was not a good thing because it was not designed super well, and they had scalability problems. I also personally didn't understand why people would want to know what I ate today for lunch. So I missed on Twitter. But technologically, at that time, we're not. But it was cool. I met all those cool people. And one of those people was this guy, Kimball Musk. He came to IAC. He wanted us to buy that company, Medium, which installed at the time toolbars in your browser to see what you do and pair you with friends and all those things. We didn't buy the technology, but I stayed in touch with the guy. And we talked almost every week. And we did what now is referred to as founder dating. And so we got to know each other. We talked about ideas, what we'll do next, and what you can do, and technologies, and interesting things. And then he convinced me to move to Boulder, Colorado, and start with him work at OneRiot, where we were indexing what people share on Twitter and Facebook. So the ranking of that search engine was based on who was sharing and what was shared. And that was a novel thing at the time. And there was interest from Microsoft and from Google and from a bunch of those things. And this guy taught me a lot. He brought with me in all those big companies and taught me how to run meetings and taught me how to do presentations. And I learned a lot from Kimball. Like I learned a lot from Alberto. I mean, what I did in life is thanks to, it started here and then thanks to a lot of people. So work for a big company and also find a mentor that will help you grow. And that's very important. Now, Kimball, the last name is Musk because he's the brother of Elon. And so those two are tremendously good things and good people, and got to meet them both and hang out with them. And I mean, their story is amazing, right? So they are from South Africa. They are about 40-something, 43 and 40. They started in South Africa. They moved to Canada to get an MBA. And then they moved to South California and they started this company called Zap2 that was basically Yellow Pages. And then, you know, when they tell the story, they say, you know, we were in our apartment, and then at some point we were showering at the YMCA to save money and all those things. And then they sold this company to Compaq and made a lot of money, a lot. And what they did with those money was interesting. Kimball decided, OK, I'm done with technology. I want to become a chef. So he moved to New York and did chef stuff. And Elon instead said, you know what? No, I can help the world. So let me build a company that builds electric cars. And then a few years later say, you know, but I can help humanity, and let me go to Mars. You know, like those small-scale projects, you know, like chef. And the other guy, but their story is interesting because you believe that success goes from here to here because we see the movies and things. But like the guys from Jive today were saying, you know, success is a mess. You don't know, and there's ups and downs and things and left and right. And you have to embrace that if you want to do this. In everything in life, this is what will happen. Unlikely you're going to be successful at the first thing you do. Another thing from those guys I learned, I loved their approach. Like, they are super humble, even if they are very a lot of money. They are super, even they are successful. They have one thing that's interesting. So when they build something, they start from, OK, what's the actual cost of this thing? So when Elon wants to build a rocket, he say, OK, if you go buy a rocket, cost X. But what is the actual cost of a rocket? If we just magically could put together all the atoms, OK, without worrying about building it, actually. You know, if you guess what is the actual cost of raw material, and the raw material is 2% of actually the cost of a rocket. And that's an interesting way to approach problems. OK, what's the actual cost of this thing when it works and if it's already done? And then to get there, everything else is overhead. So then it becomes how good you are in getting there. What's your execution plan? And often, what distinguishes good entrepreneur by bad entrepreneurs is not the idea. Ideas are free, are there. Everybody knows them. It's how to execute there. And it's interesting stuff. Like another story from Elon was he wants to go to Mars. His original idea was not to do SpaceX. His original idea wanted to go to Mars. And he figured that he could send something to Mars and be sustainable there. But to send something to Mars, he needed rockets. And in the US, he needed at least 2 rockets. And he wanted to buy rockets in the US. This is so cool. You know, like, how many people do you know that they want to buy a rocket? Right? And the rockets, each one will cost $65 million. And so he said, you know, if I buy 2 of them, I run out of money. $65 million. You know. And so he said, OK, then he flew to Russia and to buy the nuclear missile from the Russians, without the nukes, of course. And the Russians were giving him a better price, $17 million for each rocket. And then he started thinking, well, maybe I shouldn't focus on going to Mars. Maybe I'm looking at the problem wrong. Maybe what I want to do is to build the rockets and sell them to NASA and so on. And that's how they started the company. But it's cool, the idea that he wants to buy a rocket from Russia and repurpose it to send something in space. I mean, those are kind of the big thing that sometimes you want to think about. So what you want to do, you want to live in the future, and then you realize what is missing and build that. And that's a very cool thing. And so after living with them for a while, I learned a lot of things, and I say, OK, so all the stuff, that I can use all those things in my next company. My next company was this company. It was called Immersive Labs. Immersive Lab, we did something very cool, I thought at the time. We took billboards, digital billboards. We put a camera in them, and so the digital billboard will recognize if in front there was a guy, a girl, or like a kid, and your body type and so on, and will personalize what it was shown here. And while showing that, we'll look at you and understand if you liked it or not, and so improve, improve, improve. Like the best thing you could do was, if you go in the Gap on Fifth Avenue in New York City, there are 2 billboards when you enter. And before they were showing random people, random models, but now they actually look at you and show a model that kind of looks like you, which is interesting. And those billboards could do much more. We could gather analytics of who looked at them and for how long. We could have a network of them and optimize the advertising like Google does on the web, but we could do it in real life. And we could do a lot of very cool things. We were on CNN. We were this company was on a reality TV show. Like, I thought, OK, we are going to make it. There's no way we're going to fail. And we failed. And the reason we failed was because the market was not ready for us, like the same problem that the guys had. The market was not ready, so we were doing something. We basically had a super cool technology. We had a problem that we wanted to solve, but nobody else cared. And they didn't care for 2 reasons. The people that own the digital billboards, they didn't care because they didn't want the analytics. Because right now, they're telling people that in front of these digital billboards, there are 100,000 people a year that walk by, and so they can charge you $1 million. But once I go there and I tell you that there are only 30 people a day which did not even look at it, then they cannot charge you $1 million anymore. So they were not interested in somebody coming up with those. And the second problem was that the way digital advertising is sold today is this. You go to a hockey game with somebody, with the digital owner of the digital agency, and the Coca-Cola guy go to the hockey game. Between the first and the second half, the one will say to the other, I'm doing the budget for next year. Should I throw you in for $10 million like last year? The guy will say, yeah, sure. And that's the done deal. And so when I, coming from nowhere, will go there and explain to him, no, but my technology is very cool. We can tell you who is going to look at it, and you can say, OK, show this ad to those people, this ad to these people, and tell you analytics. The guy said, I just want to go to a hockey game. And I didn't have an answer. I couldn't afford hockey games. So. And so that's what we did in Immersive Labs. In Immersive Labs, we failed. So what I learned is that there has to be a market for your thing. So if you want to go in an idea, it's not always like this, but it will help you if you have an idea and do something like this. So the market needs to know that there is a problem. If you start ahead, like those guys at the beginning, they had hard times. The market needs to know there's a problem. There has to be a problem that you solve. Don't invent a problem. It's much harder to sell inventing a problem because you have to educate those people that they have a problem and now you are going to solve it. So if the market has a problem and the market knows to have a problem, which is important, like those guys very soon will learn that they want analytics on the billboard, but right now they don't. And so they don't buy my stuff. And then the market also needs to, if it's much better if they are already looking for a solution, then maybe they have a solution that is not perfect. And then you come in and you have a much better solution, and they have the money for it, and then you sell your company and you have clients. And that's the way, I mean, it's not always like this. Like, nobody needed iFart. They sold 10 million copies of iFart at 99 cents, and they got 60% of that. They made $6 million with an app that you open it, you press a button, and that's I mean, that's genius. I cannot come up with that. I did computer vision, recognizing faces, creating signature, capturing Bluetooth, and all the stuff, and I made $0. $6 million. Much better. And so when you build something, another thing, try to build something that either a large amount of people need a little, or a small amount of people need a lot. And if you can't, pick the second one. You want to build something that there are few people maybe, but these people are willing to pay a lot of money to have your thing. Because it's much easier to sell to a few people than to a lot of people. And if they really, really want it, it's very easy to sell. For example, like before they were giving this talk, and Andy was saying, when you build your company, like you can build companies of anything, and you can make assumptions. Okay, there are hundreds of millions of pets in the US, and there are owners, and let's make a Facebook for pet owners. that seems a good idea because there are hundreds of millions of pet owners in the world, and even if I get 1% of those, then I have a website with 2 million people, and I can sell the advertising to those people, and that will work out. And that's not going to work out. And you can talk to people, and if you ask your friend, what do you think about this idea, your friend would say, it could work. I'm not going to use it, but I'm sure that somebody else will, and everybody will think about the same stuff, and then you don't sell your idea. And because the markets are generally not as big as you think they are. You think the markets are big, but they are not. This is what happens often. You have this thing, in the venture capital world, they call it the 1% of China problem. You take a very big number, and you multiply it for the 1% because you think it's reasonable that you attain a 1% of the market, and then you end up with a large market that you believe it's a good idea, but it's not. For example, people will come in and say, well, there are the local contractors that do stuff is $200 billion market. And brokerage, if I build a brokerage website, capture 5% of that. So it's a $10 billion market. And if we make this little new website, which is better than everybody else, we'll get 1% of it. And so now we get $100 million a year. That's our market. That's a big number. And so you may want to do that website. Or you will say, well, there are 71 million dogs, sorry, in the US. Each spend $300 in food per year, and we capture 1% of the market, and so we will make $200 million a year. And so now everybody should want to make a dog food company because that's the market. But that's not true. Capturing, convincing 710,000 dogs to eat your food and the owner to buy your food, it's much more complicated than you believe. Imagine you going in a shop and then telling everybody, try my food, try my food, try my food. Before you get to 1 million of people that actually convert, it takes a long time. So the market is always smaller than what you think. It's actually hard to build startups in anything you want to do. I mean, they were successful, and it's awesome. But it's actually hard. And so you really need to be passionate about those things. Startups pretty much go like this. You believe you have a great idea, and then maybe you get some success because the Apple Store feature you, but then you go down. And it's hard when you go down, and you need friends. Otherwise, it's very hard. And then you don't know, there's nothing going on for a while, and then at some point, people give up because say, I need to pay rent, I need to do stuff, and so they give up. And then you execute better, and very few go in this path. They did. They are like way ahead there. And that's awesome. But very few do, so be prepared. Be prepared. If you just do this for the money, don't do it. Startups are hard work. They experience it. I experience it. It's hard work. If you do it for the money because you want to become Facebook, it's hard. Don't do it. If you want to make money, study computer science and then go in finance. It's true. Study machine learning and go in finance. Or if you are a network guy, go do that and go in finance. Shaving 10 milliseconds on a cable that goes from Chicago to New York that connects the two markets, it was worth to some people $280 million. Because they do some trading in some way. And so network guys can still do it fine in finance. There is a lot of money there. Just do that. If you want to work, if you want to do a startup, do it because it's a problem you have and a problem you want to solve. And you will do it for free. Because likely you are going to do it for free for a while before you go for IPO. So these are 3 ideas that I have that I will work on those for free. And if you do them, and I'm going to tell them to you today, and if you do them, I'm happy because I just want to see those done. And I don't care. For example, I want more intelligence phone. I want a phone that when I go to the observatory or when I go to a museum, and if I pull it out, it actually tells me, without me doing anything, what's going on, that there is a show at 3 p.m., there is a planetarium thing at 4 p.m., or there is, when I'm in a movie theater, I pull it out, and they say, there is this movie, do you want to buy the tickets? You press buy, and you bought the tickets, and just you go in. Or if I go to my burger place, it knows what I generally buy. And so when I pull out my phone, it shows me the things I do buy, and gives me the order, and now I can just wait for the order to be ready. I want a phone that's smart. I want a data hub. How many times you put your data, your address, and your email, and your phone number in every single magazine or things you register all the time. And then you move, and I move every 2 years, so this is a problem for me. And then you move, and then all your magazine, all your things, all your stuff, you have to go there and change them. It's complicated. I don't want to do that anymore. Let's put them in one place, and I give you access to my stuff for a year, for 2 years, for 3 years, and then, so if I change address, if I change phone number, you get it. I want something that pushed to me, like advertising right now, it's bad, and it's perceived as bad because advertising sucks. But if advertising was perfect, if they push to us exactly the content we wanted to, advertising will be awesome. I will want a page full of advertising that tells me, and I click on all of them. So if you do that, I want it. I want a page that say, okay, this is the books you should read. This is the music that you will like. This is the movies you should go to watch. There is a house in this place that is in your market range and stuff. There is this flight for New York on a period in which your calendar there is nothing, which costs $200, and you can go on vacation. I mean, I want content pushed to me, but in a smart way. And this is called advertising. And this is, if advertising was perfect, we will love it. Everybody will love it. And so I do that. Another thing I'm passionate about is healthcare. And I want to save the world. I want to make the world better. I wanted to do that. I didn't want to go in medicine because it takes 10 years, minimum. And it's a long, long time, but I wanted to do that. And then I figured maybe I can do something in medicine even if I'm not a doctor. Maybe we can use computer science that we know and try to do something in medicine. And the first glimpse of this possibility, I had it with the computational epidemiology group here in Iowa City that's run by Alberto and Phil. And they use computers to solve medical problem, health problem, which is an interesting thing. The first thing we did, for example, is one problem that the CDC has is like how many people are sick right now. And what they do, they ask the nurse, they ask the doctor, which asks the nurse, they compile statistics, send them somewhere, aggregate them, and they figure for 100 places in the US or 1,000 places, how many people are sick in this 2 weeks ago. There are better ways to do that. And so the way we thought about it was, I did some stuff. The way we thought about it is like, people before going to the doctor, probably they will complain on Twitter that they are sick. And that actually worked. On Twitter, you can find awesome offer for Viagra. You can find, stuff that done, eating and, I'm sick at my job, so you have to filter those things out. But what is left is people genuinely saying, I'm sick. And many more people will tell you that they are sick on Twitter as opposed to going to the doctor. And so what we did, we did that. We applied machine learning to this thing and tried to predict and compare it with the right data from the CDC and try to predict, to estimate how many people are sick. And we were successful. The blue line is the line reported by the CDC. The red line is what we are coming up with Twitter. Not only we are very close, but their reports are delayed of 2-3 weeks. Instead, we are instantaneous. We can tell you how many people are complaining today, which means how many people are sick today. And their stuff are aggregated by region, by state. We can do it on a zip code, which is very, very small. And so this was my first project in healthcare computational epidemiology, and I got excited. OK, I can do this. I can have a meaningful impact in the world. And we got the paper, and the paper was published and actually worked. And then the second step was, OK, now I know how many people are sick here. Let's try to see how those people move so I can predict where they will go next. And how do we do this? Travel models are complicated. Travel models require flight data or cell phone data. They are very expensive. But now we have Foursquare. Foursquare people check in. And so if people check in for Foursquare when they go to the doctor, they check in at the gym, they check in at the restaurant. They do that to get these awesome badges. And if you just aggregate all those data, you can track where people go. And that's what I did. All my research are very creepy stuff. And I follow people, and I track people. And I'm not going to tell you today, but generally in conferences like this, I monitor the Wi-Fi, so I can see how many people are on Wi-Fi during my talk and during the other talks. And I compare that. And so that is a metric of how interesting I was or how I was not. Right? If everybody's checking emails, then you're not that interesting. So I do way worse. And so aggregating the data, one person, these are all people. Red one is one person, blue one is another person, and you can see where they live, and you can see where they work, and you can see other stuff, and you can do that at a bigger scale. This is how the US moves. These are airports and check-ins in airports. And so perfect. Now we can use that in a travel model. And that was the paper. So now we can get sick people, we know where they're moving, and we can start doing some real medicine, some real prediction things. And now that you have all those devices that calculate things, that they measure your weight and your sleep and all stuff, and they tweet about it without you knowing it. And you can collect those data, and you figure out, OK, people in California go for runs, so people, how much people run. You can figure out how much people weigh. Are they, you know, the red is where they are heavier, and like, you know, this is where they are heavier, I believe. Yeah, the red is where they are heavy, something like that. Statistics. You can also do monitor. Okay, now I have 3 channels. I see people on Foursquare, on Twitter, and Runkeeper. This is the activity of one person during several weeks. Okay, on all those 3 things, and you can see that there is a week there which is doing less. Maybe that person is sick. Can I calculate? Can I build an algorithm that detects when people are sick because they generally run and they don't go? I mean, it's possible that he went on vacation, but it's also possible that he was sick. And so that's some more interesting stuff you can do with computation and medicine and things, because the point is to save the world. I always wanted to do that. And so, you know, there are many ways that even if we are not doctor and we are not Superman, we can help that. We can try to help saving the world. Some research that they did, somebody else did, you know, this is Iowa, and these are, you know, collection sites for like influenza, like I was telling you before. There are some doctors that report influenza data to the CDC. These are the current centers, and they cover 39% of the population. If you just move them, maximum 20 miles, you cover 70% of the population. So this is just computation. There is no doctor involved here besides knowing where the doctors are. But we recomputed where the locations are, and now we cover 70% of the population. And this thing was applied also to stroke centers. There are some, you know, when you have a stroke, it's better if you get treatment right away. And if those treatment centers are far away, because there are only a few in Iowa, that's a problem for you, because you cannot get there in time. And so we applied machine learning, and we computed the location of those centers should be, so that 80% of the population are covered. And if 80% of the population are covered, instead now it's, I believe it's 35%. Let's assume it's 35%. If those cover 35%, and now we go to 80%, I mean, that's a big difference. You are saving lives, actual lives of people, because now they can get to the heart attack center, stroke center when they need to. But, you know, like, let's think about, okay, you don't want to do medicine. No problem. UPS, in 2004, implemented something that is known as no left turns. So the data scientists there decided, they recalculated the routes of everything, and they decided that when they do a left turn, they have to change lane, and that's an expensive operation. It's expensive in terms of time. It's also risky. There are accidents happening when you have to change lanes. So they decided okay. So they recomputed all their routes, so they only turn right. And they save time, and the delivery things improved, and they have less maintenance because they have less accidents. And they also save 10,000 metric ton of, okay, so they reduce their impact on pollution of 10,000 metric ton of carbon, which, given the impact that that has on people, blah, 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 if you do some calculation, extrapolation, that saves 100 lives per year, because those people will not get sick because of pollution. Self-driving cars. There are 2.5 million of accidents every year in the US. 38,000 people die every year for car accidents. If you guys build a self-driving car, you reduce that. You save 38,000 lives per year. That's pretty cool. And, you know, and that applies everywhere. So what I did the other day was, there is the Man of Steel, the Superman movie. And in the entire movie, Superman saves 38 people. And if those are, you know, in medicine we do quality years, quality of life years. So if every one of those 38 people had 50 years, the Superman basically improved the world of 1,900 quality year life. In my current job, I get to play with data from insurance companies. Like, this is the only one I can talk about. But Humana is a big insurance company. They have 5.5 million people, and 30% of those people have a chronic condition. So let's assume that I'm smart and I do something that changes, that improves the life of each one of those people of one day. Because I do early detection, because I improve the thing, because I better drugs, whatever I do. One day. I give one extra day of quality life to each one of those people. I get to, 5.5, what else, 30%, 2.5 million people. I give 2.5 million quality days of life, which translate in improvement in the world of 4,500 quality years. So I'm doing 3 times better than Superman. And that you can do everywhere. I showed you. You can do UPS, you can do stuff, you can apply computer science to a lot of things and actually have an impact in the world. And so you should go and do that. And that's mine. Here's a question. No, you do.
Okay. Seems like you were ahead of your time with this smart billboard. Was a patent an option? Because if you're ahead of the game and you patent something, then later on somebody else develops it, but you get a cut of that money.
That is true. That is true. You can play the patent game. So when you have an idea, you could patent it. And so if if you are ahead of the market and somebody else comes there, patents are true. That's one way. Patents are expensive. They cost $10,000 if you want to a non-provisional patent. So sometimes when you have a startup and you're renting very small space with no windows and blah blah blah, you don't have $10,000 to do that. Also, patents have to be fought. Even if you have a patent, somebody will, you have to go after people with your patent, and they have generally more money than you. And I mean, I was not in there. That was a great idea I cared about, and that's something I wanted to work on, and it didn't work out. So, the thing is that in the slide that I showed you here, 75 slide before this. Okay, this one. So this is a bad time. So in startups, it's not a problem if you fail, in my opinion. As long as you move up or down, you are fine. The problem of startups, you're in a startup, is when you move horizontally. So where you're actually not making that much progress, when you're just hanging in there, not moving up or down. And that's the period in which you're stuck for a long time, and that's the time you have to evaluate if that's worth for you or not, or if you should move on to something else. Failing is okay, in my opinion. Just to have to fail fast. I mean, in life, we do it all the time. We date a lot of people, and you go on a date, and then you say, no, that's not working. And that's fine. And the same thing is in everything else you can do. I mean, you have to put effort in some stuff to achieve what you want. But in that particular case, we had a lot of fun. I told you, we were in a TV show. We had a lot of cool things. And we really believed it was going to happen, and then it didn't. And I moved on. I did something else and something else and something else, and I'm very happy of that. And maybe if I had stuck longer, who knows? Maybe it would have worked, maybe it didn't. But sometimes it's not worth to wait. You cannot ask questions. You went IPO. Come on. I didn't actually come back. So, after Ask.com, I mean, when I got the offer from Ask.com and Google and everybody, I went to Alberto and I said, Alberto, I have these offers. What do I do? And Alberto said, yeah, those offers are very good. You should go. And so I actually went there, but I continued to, I did almost all the classes. And the only thing is, I mean, I was a PhD student for like 10 years. I graduated in December 3rd, because December 4th, I was informed that my classes from the first semester would expire. So I couldn't hang in there anymore. And so I had a hard deadline, and so we established. I did research in those years, so the research you have seen came up during those years. So I was doing my career and working on research here, but I just didn't write thesis because every time there was the most shiny things for me to work on. And Alberto stuck with me, and I was very generous of everybody here, and Catherine and Cheryl, everybody, and Professor Herman. So I owe my degree to everybody, a lot of people in this room. Otherwise, if Cheryl and Catherine didn't remind me all the time to register for classes I will have never have.
This is not the recommended method.
That's why I skipped that part on the degree. I said, just mention I got a PhD. Somehow. Yeah, you should not do that, but it was fun. Nobody has questions. That's good.
Thank you very much.
All right, well, thank you, everybody. That was our final speaker for UICC, at least for the student portion anyway. After this, probably around 4:45, we'll be announcing the door prize winners as well as the puzzle comp winners as well. And then later tonight, around 6 o'clock and 6:30, we'll be having our gaming/LAN party over back in McLean. However, I know the alum have a special event coming up at 6 o'clock. It's the alumni dinner
The athletic club.
at the athletic club. Do you have anything you want to say about that?
Yeah.
I might as well. You're already just yelling at me.
So for the alumni who are registered for the dinner, it's at bar opens at 6 at the athletic club on Melrose Avenue. You'll remember where that is, other side of the stadium. And maybe a good idea for those of you with cars and those of you without cars to sort of work out a transportation plan to get to the. There's plenty of parking there, but it is quite the walk in the cold. Thank you very much.
Thank you.